Okay, this is the lesson on atmosphere layers and composition for the Earth and Environmental class. The objective we're going to cover today is EEN 251, summarizing the structure and the composition of our atmosphere. This is extremely important because this leads us into our discussions of whether it makes sure we have a basic understanding of the atmosphere, how it works, that type of thing. So for starters, let's talk about something I want you to do. This is a task that I want you to accomplish. You can do this while I'm going through the video. You can replay the video just to make sure you're covering everything. I want you to do a drawing or a diagram of the layers of the atmosphere. Okay? Now, before some of you just throw 4 lines on a paper and put titles down and think that that's it. You've got to cover a lot of information on this diagram. This diagram is going to be your guide as you move forward. So you're going to have to include the layer names, each of the layers. You're going to have to include the temperatures of each layer. Now, some of them are going to have actual temperatures listed. Some of them will not, but will say, okay, this is a layer where the temperature goes up as you go up, or this one was a layer where the temperature goes down as you go up. So you're going to have to make sure you have that on there. Chemical makeup of the atmosphere, so you're going to have to know what gases make up the atmosphere. There are some very specific layers that have some very specific makeups. You're going to have to know those. And also how those layers interact with radiant energy. So these are the 4 things that we're really going to cover with this lesson. Okay, so if you look at mine, I have done exactly what I asked you to do. Like I've always said, I don't ask you to do anything I'm not willing to do myself. Mine's very busy. There's a lot of information on it, but it's okay because I know what this information means. Yours needs to be this busy, not messy, but you do have to have a lot of information on it. All of those things on that screen are on this right here. Okay, so that's what you're going to be focusing on as we move through this. So the basic layout of the atmosphere. Okay, so the Earth, the layer that's closest to the Earth is called the troposphere. The stratosphere is the area above the troposphere. The mesosphere is above that. The thermosphere is above that. And the exosphere is above that. We're going to talk about each one and why they're important. So remember, you need to include the layer names, the temperatures, the chemical makeup of the atmosphere, and their interactions with radiant energy. So basically, this is the idea. So if we start at the bottom, and I've got another slide in a minute that has more information on it, but I'm going to kind of break this. There's a lot of information on the slide. I'm going to kind of break it down for you. The troposphere goes from the Earth up to the stratosphere. It's about 10 miles from the Earth to the stratosphere. Now, it's 10 miles at the equator. This is important. It's 10 miles at the equator. However, the troposphere is only 5 miles up at the poles. Remember how we talked about how the Earth is squished? The Earth it's a circle, but it's squished because it's rotating so fast that the outsides kind of squish out and the top kind of squishes in. Same thing happens to the atmosphere because of that. So the atmosphere squishes. It's about 5 miles at the top and the bottom, and at the equator, it's about 10 miles. Okay, this is temperatures can get as cold when you get it going up the troposphere. It gets colder. When you get to the top of the troposphere, it's about a negative 103 degrees. Okay, now what's important here is this part of the atmosphere is where 75% of the atmosphere is located. So we're talking about the things that make up atmosphere. We're talking about oxygen and nitrogen and argon and carbon dioxide and water vapor, all of these things that make up atmosphere. 75% of that is in this spot, troposphere. Okay, so we go above the troposphere, we get to the stratosphere. The stratosphere is from 10 miles up to 31 miles up. Okay, as you go up in the stratosphere, the temperature gets warmer. So the troposphere, it gets colder going up, then the stratosphere, it gets warmer going up. Okay, until you get to The ozone layer, which is in the stratosphere, that's the protective layer. And we'll talk about the ozone layer again in a minute. But that's the protective layer. That's at about 14 miles. So it's about halfway up the stratosphere, or actually a little less than half up the stratosphere is the ozone layer. That's a protective layer. That's where the ozone layer is located, in the stratosphere. 20% of the molecules in the atmosphere are in this layer. So 75% of the atmosphere is in the troposphere. Another 20% is in the stratosphere. Well, if you do your math, that only leaves 5% left of the atmosphere to go in the other 3 layers. Okay, so our math is showing us that most of the air is in these 2 layers. Okay, that gets us to the mesosphere. The mesosphere is from 31 miles up to 50 miles up. So we're going in layers. This is where meteors, when you see a shooting star or a meteor shower, this is where the meteors start to burn up, and it's where they burn up, most of them burn up. As you go up, the temperature goes down. So the troposphere down here, as you go up, the temperature goes down. When we get to stratosphere, as you go up, the temperature goes up. And then when you get to the mesosphere, as you go up, the temperature goes down. So it's this process of up and down on temperature. The top of the mesosphere, where it meets the thermosphere, is about negative 130 degrees. Then we get to the thermosphere. Okay, the thermosphere, it's called the thermosphere because this is where the temperature really rises. So the stratosphere and the thermosphere, the temperature rises as you go up. The mesosphere, the troposphere, and the exosphere, the temperature falls as you go up. Okay. Now, the thermosphere is where the ionosphere is located, I-O-N-O-S-P-H-E-R-E, the ionosphere. That's basically where all of the particles in the atmosphere are charged. They have an electrical charge. And those electrical charges can interfere with radio broadcasts. But also, this is where the magnetosphere is. So the ionosphere and the magnetosphere kind of work together. First of all, the ionosphere, because it's charged particles, it's what helps create the magnetosphere, which is the Earth's magnetic field. It's also what creates the northern lights, what we call the aurora borealis. You've seen pictures of the aurora. It's kind of that greenish orange waving, looks like it's waving, but it's up in the sky. That's because of the ionosphere. Again, it goes up from 50 miles to 400 miles. This is the largest of the layers. Thermosphere is the largest of the layers. And then you get to the exosphere. That's basically outer space. So that the exosphere goes from 400 to 40,000 miles. Okay? But the exosphere isn't actually thought of as a layer. It's where the atmosphere actually starts to become space. So we don't think of it as a layer. All right, layers of the atmosphere. Here's kind of a breakdown to make it very specific. Troposphere is where most of the temperature is, or excuse me, where most of the atmosphere is. The temperature goes down as you go up. And then the troposphere, when it does get warm, it gets warm because the ground warms it up. Okay? This is where all of our weather is located, in the troposphere. So most of our discussions on weather as we move forward are going to be limited to the troposphere or maybe the stratosphere, but these are the 2 spots where most of the weather takes place. The stratosphere, temperature goes up, the ozone layer is here, and the pressure is very low. The mesosphere, it's very cold, meteors burn up there. And then the thermosphere, temperature goes up as you go up. It's got low pressure because there's very few molecules of air. This is where the International Space Station is located. And it's also where the aurora borealis, or the northern lights, are located. Now, we talked about chemical makeup of the atmosphere. This is where it gets important. Okay? So the atmosphere is made up, and remember, where's the atmosphere located? In the troposphere. Atmosphere is located, that's where most of the atmosphere is located. Nitrogen is the most abundant substance. It's the most abundant element that's in the atmosphere. Nitrogen. 78% of our of our atmosphere is nitrogen. Your body can't process nitrogen. So when you breathe in that 78% nitrogen, you just breathe it back out. It doesn't stay in your system. 21% of the atmosphere is oxygen. That's what we breathe in, and then we breathe out carbon dioxide. Argon makes up about 1%, and then the trace gases make up about 1/10%. So 1/10% is trace gases. Well, what are our trace gases? That's what gases make up that 0.1%. Okay, carbon dioxide makes up about 94% of those trace gases. So 0.009% is carbon dioxide. Then neon, helium, methane, nitrous oxide, and ozone make up that remainder little piece of 6%. Okay, so there in the blue, that's what the atmosphere is made up of. There in the red, that's what those trace gases, that little spot right there that says trace, that's what all those trace gases are, is that right there. You'll notice ozone is there, and we're going to talk about that. So the ozone layer, we said, is in the stratosphere. It's about 14 miles up. The ozone layer, and you can see here, ozone molecule is 3 oxygen atoms connected together. Now, the role of ozone, 3 oxygen atoms connected together, is to protect us from UVB light, ultraviolet B light. Ultraviolet B causes cancer. So we like there to be ozone in the stratosphere, because the more ozone there is, the more protection we have from UVB light. The problem is that ozone breaks down very easily, and how it breaks down is like this. You have a CFC molecule. Now, what's that? Well, the specifics on the screen there, CFC is 3 chlorine molecules, a carbon, and a fluorine molecule atom. That makes up a CFC molecule. Well, what is that? That's the chemicals that they put in hairsprays, in refrigerants, when they have to put new refrigerant in your refrigerator or in your air conditioner or your car air conditioner. Things like halons that are in fire extinguishers, methyl bromide, which is a pesticide they put on plants to keep bugs off of it. These things, CFCs, HCFCs, halons, and methyl bromides, all affect the ozone layer. Excuse me. What happens is that CFC gets up into the atmosphere, the UV light hits that CFC molecule and breaks off one of those chlorine molecules. So right here you see, number 1, that chlorine molecule being broken off by the UV light. Well, that chlorine molecule, if you remember our discussions about how stable and unstable atoms are, chlorine is one of those unstable atoms that has to attach itself quickly to something else. Well, it's going to attach to an oxygen molecule. So it's going to hit that O3, and it's going to break off one of the oxygens and take one of those oxygens for itself. Well, that gives us an O2 molecule, which is our normal oxygen. You're like, what's the big deal? We breathe oxygen, so that's good. The bad thing is we don't have that ozone molecule anymore, which protects us from the UVB light. So those CFCs break the ozone down into oxygen, and now we don't have enough ozone to protect us from the UVB lights. So that's why this is so important, is to understand that when you're going out to buy things like hairspray, you're going out to buy deodorants, if you use a spray deodorant, to check the can and make sure that they do not use CFCs. Most of them are required now not to put CFCs in, but some of them still get away with it. So you have to make sure you read the labels. I hope that helps you understand ozone a little bit. Ozone, and don't get confused, because you're going to hear people talk about, I just remembered this, so I'm throwing this in here. You've heard people talk about, well, the ozone levels right now are at a dangerous level. Okay, you'll hear people talk about that, especially during the summer when it's really hot out, and they'll talk about how the ozone levels at ground level are very bad. That's true. Ozone at ground level, that's the troposphere. In the troposphere, you can see the troposphere here on the map, on the diagram. Ozone in the troposphere is bad because it stores energy, it stores heat. So when that UVB comes, it grabs onto that and then it heats up. That's why the stratosphere, as you go up, the temperature increases, because those ozone molecules are grabbing that UVB energy and they're holding on to it, which means their temperature goes up. That's why the stratosphere temperature goes up. Well, when the ozone is at the ground level, troposphere, down where we are, and it does that, it increases the temperature. It makes it hotter than it should be. So ozone at ground level is bad. Ozone at stratosphere is good. So hopefully that's cleared up a little bit for you. If you have any other questions, this is a pretty fast lesson, but I can go back over some of this if you need it. Just come see me on Microsoft Teams, and I'll be happy to chat with you. Have a good day.